Welcome to day 1.
So as you're already aware, we're going to learn IBM, CICS. Okay, CICS was launched by IBM during 1980s. It's a OLTP. OLTP means online transaction processing. So we can execute online programs in CICS. As you guys are already a senior people, so the training is going to be based on your experience. If it's a fresher, I'm going to take how to spoon feed right from everything. Since you're already aware and have seen or used CACS a little bit, I'll just skip a little. So as you're aware, we are going to develop the programs in PS environment and we're going to execute in CACS environment. What is CACS? The CACS is a subsystem, okay, which is running where? Which is running as a job. As a job. Okay, as a job in PSO environment. Okay, in fact, it is running as a job in under JES. Okay, J is a subsystem. Okay, we call it as a primary subsystem. Under that, a cics is running, which is a secondary subsystem. So, for example, we take IBM mainframe hardware. Okay, it's operated by ZOS. Okay, the latest hardware which was introduced in year 2000. Okay, year 2000 was IBM some Z15 and Z16 was the hardware, and they introduced ZOS 2.6 version. The ZOS 2.6 version. So this is the operating system which is going to operate the hardware. So under this hardware, we'll be having, okay, basically a master subsystem, and then we'll be having JES. So CES is a subsystem which is running as a job in TSO environment. Okay, and this provides a platform in which online transactions can be executed. And online programs are developed in TSO environment. And this is the IBM mainframe hardware, which was introduced in 2000, is Z16, and then 2.6 version of ZOS is running. Under that, we have JES. JES stands for Job Entry Subsystem. You would have heard about JES, right? Job Entry Subsystem. It's a primary subsystem. Under this subsystem, all the jobs in mainframe will run. Okay, any job in mainframe will run under JES. It could be any secondary subsystems, or it could be a user ID. Okay, because your user ID will itself run as a job, right? When you log on, you can see in the spool, user ID will be running as a job, and any user will be submitting a job. That is a user submitted job. So all these jobs will be running in J under JES, either JES2 or JES3, which your system, which your shop is using. And secondary subsystem like we have DB2, CICS, IMS, etc. Okay, this runs as a job. But what this is going to provide? Okay, CICS is going to provide a subsystem means what is subsystem? You would have heard about subsystem, right? Subsystem means it's a service provider. This is the actual definition. Provider that does one or more functionalities. Okay, one or more functionalities. Okay, if requested. Only if requested they will do, otherwise they won't do. And CICS is a subsystem which runs as a job under JES. Okay, if you go to spool, if you give owner star 3 star, you can see all the CICS jobs are running. So this provides an environment. Okay, this provides an environment. Okay, this provides an environment to execute online programs. Okay, and execution of online programs is called transaction. So and execution of batch program is called jobs, as you're already aware. Both of you are seeing it. So it provides an environment. Okay, it's going to provide an environment to execute online programs, and the execution of an online program is called a transaction. Okay, and this consists of major components. Okay, let's quickly go through major components, CICS components. So if you see a CICS component, there are three major CICS components. One is control programs. okay, and control tables and control areas. Okay, these are the components. So these components means all our system programs. Remember, in a software, it could be either a system program or an application program. All these are system programs, which is going to aid application program. Okay, which is going to aid application program and created by the application programmer. When an application programmer writes a program, okay, or a map set and executes, these three are going to support. So what does control programs do? So control programs primarily going to there are different control programs. I'll just show you X CPT straight away. So basically, it provides an interface between operating system and application program. So all these are going to be interfacing because now we have. Let's come to cics alone. I'll remove say IBM mainframe. We have ZOS. Under ZOS, cics is running as a subsystem, secondary subsystem. Under cics, cics is going to comprises of what? All these components. Okay, three components, three major components, and then they're going to have application program. Okay, so this is the actual diagram which you have to know. An application program, whatever we are creating in PS2 environment, in order to execute, we log on to cics region, and in cics these are the control programs available, which is going to help in executing the application program. So you can say a cics component acts as an interface between operating system and application program. Okay, so this is what is happening. So there are many control programs, and for equivalent control programs, we have control tables. We can't execute any program directly in cics. So we need the components. I mean the components like we need programs, or it could be files, okay, or databases that to be defined in tables. Tables means again it's a file. It's going to be stored in a file, and again administrator is going to maintain the tables. We have our server, okay, so we can log on and we can write, create transaction, create program. So we can define the tables on our own. I'll show you. I'll just probably write small program and execute and show you. I'll define a table. I mean, define an entry in a table. Okay, then I'll write a small program to send a text. Okay, then I'll execute the program and show you today. And then we'll log on and go to map set. Okay, BMS map set. So today we'll try to write, execute small program. Then we'll understand some concepts on pseudo conversation. So that is very important. Okay, but next week, tomorrow I'll write. But what time we are meeting? So that we can plan accordingly. Okay, so we need programs, files, databases to be defined in tables, and this is done by administrator. Okay, by admin, cics administrators. So there are different programs, and there are tables, different tables available. For all these definitions, and we're going to provide storage for any task to execute. Okay, any task to execute. Okay, control programs are programs that acts as an interface and OSs. Okay, to provide services requested. What are services requested? So suppose you are going to read a file, write a row, insert a row in database. So that's a service requested. So when a service is requested, corresponding program will be invoked, and it will be getting data or inserting data from the database or a file. So these are the services. Okay, all these services are, whenever it's requested through the program, will be processed by control programs, and control tables will have all the components, all the components. Okay, all the I mentioned as programs, files, and DBs, etc. to be defined. To define. Since you went through the, I mean, video, I mean, I'm just going quickly. I'll share you a couple of PPTs today. So whatever I'm showing as PPT and writing, and I'll just show you. So I'll just quickly go through. cics is a subsystem which is running as a job in TS environment. If you go to any project, you can see a cics job running. Okay, with the same name as region name. Okay, cics is a secondary subsystem. Under that subsystem, you can write any application program. It is going to aid in executing application program. And what are the components which is going to help in executing application program? We have control programs, control tables, and control areas. Okay, if you have any doubts, you can ask me then and there. And we have some terminologies to be learned, like tran code, a transaction code, and we have to know what is a transaction. Okay, these are interview questions also. What is a transaction? And we have something called multitasking. Okay, we have re-entrancy, quasi re-entrancy. So these are some concepts we have to know, and we have to know what is a task. Okay, these are some concepts you have to know before starting entering into writing programs in cics. I will show some control tables and control programs. Before that, we have to know what are all these. Transaction means executing an online program is called transaction. Executing an online program is called a transaction. Execution of a batch program is called a job. I think you guys have clear understanding about what is an online, what is a batch program. Okay. So if you have any doubts, you can ask me about anything, whatever I'm teaching. As far as online program is concerned, the data is prepared at the time and executed and given to the program. An online program can have a map set, it can have a screen. An online program preferably execute only one data at a time, only one data, and it responds immediately, almost immediately. That's why it is called as real-time program. So probably it responds in less than 3 to 4 seconds. Okay. So and let's come to task. Execution of a program. Execution of a program is a task. Okay, accessing file is a task. So everything is a task. Accessing data from a file or database. Okay, accessing data from a file or database is a task. Okay, so people will be asking about, I mean, what is task in interview question? You can probably say execution of a program is a task, and I mean accessing in data from a file, everything is a task. Writing data into a file database is a task. For every task, there will be task ID created. I'll show you once we write a big program. Probably next week we'll be writing a big program. Today we'll write a small program which is a non-conversational program. Okay, I mean just non-conversational. So let's come back here. Let's see what is a transaction code. If you want to execute a batch program, then we need a JCL because ZOS doesn't understand a program directly. We need a JCL as an interface between ZOS and the batch program. Okay, similar, but for execute an online program, we need a transaction code. A transaction code is a 4-byte code that is used to execute an online program. Okay, this transaction code will be entered on the top left corner. In the top left corner in a cics screen. Okay, a transaction code is a 4-byte code that is used to execute an online program, and this transaction code will be entered on the top left corner in any cics screen. This you are already aware. Okay, and a transaction code should also be defined in control tables. Okay, a transaction code will be defined in control tables. Unless it is defined in control tables, it's not going to work. Apart from defining the transaction code in tables, you should have access. Okay, the administrator should give access for a user ID so that they can execute the transaction code or program. Okay, the transaction code is a 4-byte code that will be linked to an online program. Okay, it doesn't mean all online programs require a transaction code. There could be a called program or we call the subroutine. Subroutine need not have a transaction code. Okay, subroutine need not have a transaction code, and and there could be more than one transaction code attached to a same program. So we can have more than one transaction code attached to a same program. So this is quite rare. Okay, you will not be seeing very regularly. In some installation, they have given more than one transaction code attached to a single program. Okay, so that's a, that's quite different, and in some installations they have used. Okay, so now coming back to multitasking, as you're already aware, multitasking is executing more than one task at the same time. So these are concepts of operating system also, ZOS also. You would have learned very long time back. Okay, on the concepts of operating system like multitasking, multi-programming, and multiple virtual storage. Similarly, these are the concepts, okay, which you'll be expected to know as far as CIC is concerned. Now let us look at what is a quasi re-entrancy. Okay, generally you would have heard about re-entrancy when you learned MVS operating system. Okay, ZOS operating system. The earlier versions of ZOS is called MVS operating system. So we used to call it MVS OS 390, MVS OS 360, and the latest version, which was introduced in 2000, okay, it was called ZOS. And today we have ZOS 2.6, okay, which is the latest version introduced in March 2024, okay, this year only. But from 2000 till today, it's called as ZOS. To come to quasi reentrancy, what does it mean? Suppose the program is interrupted. If a program is interrupted, okay, and if the control goes to another program, and if you come back to the old program, come back to the old program, okay, the old program we can execute the old program from wherever we left off. We can execute the old program from wherever it left off. So this is called quasi reentrancy. Wherever we left off. So it's quite common. Okay, you would have seen in our day to day life. We are using a lot of applications in phone. Okay, at the same time. Sometimes we'll be opening one application. Suppose you are filling a form, you don't know the Aadhaar number. We go to WhatsApp or we go to photos and come back again. Okay, when you come back again, if it is going to be in the same position wherever you left, it's called re-entrance. If it is not going to be there, okay, it is going to refresh. It will go to the top. Okay, again we have to start filling from the top. We can say there is no re-entrance. Okay, so if a program is interrupted, and if the control goes to another program, and if you come back to the old program, okay, if it has a capability to execute from wherever it left off, that's called re-entrancy or quasi re-entrancy. In batch program, we call as a re-entrancy. Okay, in CICS, we call as quasi re-entrancy. So these are the major concepts you have to know as far as cics is concerned. Okay, I'm not going to get into programs and areas in detailed manner, but we can see the tables. So we can see the tables. Okay, so if you have any doubts, you can ask me. Let me open a slide. Okay, you can see some table. A PPT means program control table. PPT will have all the transactions, sorry, all the programs to be defined in PPT. Okay, PPT. PCT is a program, I mean, program control table. Okay, you just don't see this, see this. The control table. Program processing program table is PPT. Program control table is PCT. File control table is FCT. So for every terminal, okay, we have TCT, terminal control table, and we have something called temporary storage queue, TSQ. You would have heard about that. Again, TSQ can be defined in TST. TSQ can be dynamically created, or it can be created upfront in TST. These are some tables in which you have to enter. If you're going to have some transaction codes, it has to be there in PCT, program control table. Unless it is present in PCT, it can't exist. Similarly, when you're writing in PCT, you have to write transaction and program together. Okay, because you have to know which this transaction is mapped to which program. That mapping is done in PCT. Today, I'll enter using SEDA. I'll create an entry in PCT. Then you will know how it is linked. It's very easy. So the transaction program linkage happens in PCT, program control table, and program is defined in PP. In all files, okay, any KSDS file or ESDS file which are using in online should be defined in FCT. And remember, there will be a file name, shortened file name, 8 bytes file name. A file we call it as a logical file name. Like how you have a logical file name when you're writing a batch program, like select logical file name assigned to DD name. Similarly, there will be logical file name which will be mapped to a dataset name, okay, DSN, and this logical file name will be defined in FCT. We'll be doing all the entries by ourselves because in our server we have admin access. Okay, we have admin access. Because of admin access, we have access to a command called SEDA, CEDA. Using SEDA, we can give entries. We can add entries to the control tables. We can add transaction. We can add programs. We can add files, any visa files. We can add, and again, we can add any temporary storage. And we have something called TDQs. When we can add TDQs, we can add data DB2 tables. We are not going to add DB2 tables. In fact, we are going to give plan names. So all these we'll see in slow and steady. Okay. Now I'll go to the slides. Okay. I think since you have already seen the slides, I'm not going to deal with more with the slides. And remember, in mainframe environment, every subsystem will run in a separate address space. So like JES or TSO is a subsystem, CICs is a subsystem, IMS is a subsystem. Everything will be running in a separate address space. That's what is shown in this slide. Okay, all these are not required. So these are the languages we can use in CICS. You can use either COBOL or Assembler or PL-BOR1 or C and C++ Java. So in projects, mostly it will be COBOL. COBOL is widely used in compared to writing a cics program through Assembler or PLI. These actually are already told. So we saw about the three-tier architecture. In a three-tier architecture, we'll be having presentation logic, business logic, and the backend. Probably I'll show you one important slide on the evolution of mainframe because I just draw one diagram. So we have some definitions here, like what is a task? A task is the execution of application program for a specific user. So, can ignore about the files, okay, accessing files and database. That is also a task, but this is a major task. Execution of program is called a task. Okay. So within CICS, multitasking is possible because more than one task can execute at the same time. Okay, so how multitasking is possible? For example, we have transaction. Okay, we have a transaction called ORD, or order entry. Okay, order entry, ORD1. If there are, 100 people working in the order entry, all 100 people in the business side, they'll be coming to office, they'll be logging on, they'll be logging on to the main. This assume this is the main transaction. Then we have sub menus. So creating menus and sub menus are very very easy. Okay, creating menus and sub menus are very very easy. Once you complete the training, you can create menus. You can have user ID and password for the main menu, then sub menus. Okay, and going from one menu to another menu is very easy. Suppose we have a main menu, okay, and there are 100 people of running the main menu. For every person, there will be a separate task running. Okay, there will be a separate task running. That's what. Okay, so there are 5 users who are executing different tasks. It could be a same program. So you can see this program and this program is same program. Okay, if the user is executing the same program, means there is only one load module available. Okay, there is only one load module is going to be available in the fixed region. Okay, there'll be one thread for this user, another thread for this user, and that is called multi-threading. Okay, so we can see. Now we are seeing the in the next screen. Assume both the order entry program is executed by two users, user one and user five. Okay, user one is going to use the same load module. It's going to be only one load module in the system. So there'll be one thread and working storage, and for every user there'll be a different address space. Okay, and then they are executing the same program. Thread means we can assume as a cursor. Okay, cursor. So multi-threading is also a important concept. Okay, in fact, I didn't write multi-threading, but multi-threading is also an important concept. Okay, now this is important. I didn't show this slide. Suppose if I enter a transaction, okay, if you enter a transaction, say ORD1, the top left corner, what system will do? System is going to check whether it's a valid transaction code and you have access to the transaction code. Okay, before executing a transaction, okay, it is going to come to a table called program control table, PCT. So in PCT, all the entries will be there. Okay, all the transaction codes will be in PCT, program control table, and the program which is linked to the transaction code will be in PCT. Okay, so unless there's an entry in PCT, the transaction will not execute. For example, let me log on to mainframe. Just hold on. Let me log on to mainframe because you can't execute any cics programs brand new in your project. Suppose I'm logging on cics OSA region. So my ID is OSA 100. Links is the password. Suppose I'm writing ABCD on the top left corner. Okay, ABCD is working. ABCD is working. When I write ABCD, it is and press enter. It will check where? It will check in PCT. Okay, it will check in. I'll write here. It is going to check whether ABCD is present where in PCT. Program control table. Program control table will contain what? Transaction code and program name. Then the control will come to PPT. PPT is program processing table. Okay, PPT. In program processing table, we have program, okay, and then location of load module. Remember, okay, a load module will be in PDS, okay, in a dash D. Okay, everything is in dash D. PS or PDS, everything in dash D. Okay, but for kicks, we have a separate memory. We have a load model library which is in kicks region itself. Okay, the main thing behind that is, for example, so let's go to mainframe again. We have a dash D. So we have something called main memory. In dash D we have all the files, load modules, databases, programs. Okay, our entire software is in database along with data. Now in main memory, okay, your kicks is running. So whatever you're executing is going to run in main memory because that is like RAM. The kicks program is running. Kicks environment is running. The program is running. We have so in CIC environment, so we store load module in kicks environment itself. Okay, is stored here. So in kicks environment, we store the load modules. Okay, it will be in PDS load library also. Okay, it will be in load library. Okay, but we store in CICS environment. The main reason behind this is to improve the performance. If it is going to be here, every time a user executing transaction, it has to bring from here and load here, right? In the kicks memory. So to avoid that timing delay, kicks region, we store the load modules. But if the program is written for the first time, okay, it will not be in kicks region. Okay, when you suppose you write program for the first time and it is defined for the first time and created, you wrote the program and you are going to execute for the first time. If it is first time, it will not be in kicks memory. Okay, we have to bring it from load module library to kicks memory. Second time onwards, okay, second time onwards, if you are executing, it is going to take the copy from kicks memory itself rather than bringing a fresh copy from load module library. It will never bring fresh copy because of performance issues. It is going to look for the program name in kicks region itself. If it is present, it is going to take and execute. If it is not present, it will take from there. Okay, that is going to be only first time. That's the reason when people develop programs and they compile and create a new load, the new load will be in PDS library, right? So it will not be in the kicks region. So whenever there's a new load, you want to bring those load to the kicks region, you have to give new copy. People give new copy so that new copy of the load model will come to the kicks region. Okay, so that kicks is going to pick the new load model. Otherwise, old load model will be in kicks region. Okay, the location of load model will be mentioned in PP. Okay, the location, whether it is in DASD or it's in fixed memory, okay, you can see here in storage on disk. Okay, it is in storage, fixed storage itself. On disk means the DASD. Okay, if it is on disk means it's going to be from DASD. So, so we can say, so these are two um, values. Okay, in storage, meaning fixed storage. Okay, I'll write it like this, or dash on disk. Disk means dash. Dash D means load module library. Okay, load module library. Once you compile it, it's going to store in load module library, right? So it will be in dash. So if it is in dash D, it has to pick from dash D, bring it to kick storage, and execute the program. If it is in kick storage, it is going to execute the program directly. And remember, everywhere will have the user ID also. Okay, user ID and access level also. What level of access you are going to have? I'm going to read where you can do editing also, etc. Okay, based on that, it's going to allow. Okay, all these are set by RACF administrators. RACF administrators are going to set the rules for accessing the transaction. So very simple. If you type the command, okay, transaction code on top left corner, it is going to check in PCT. If it is present in PCT, it will know the program name. Okay, here in PCT, the transaction code is linked to the program name, and it is going to check whether the program load module is in the quick storage itself or it has to pick from the dash. Okay, all this information will be here in PPT. If it's in dash D, it is going to pull the data. It is going to bring the copy of load module to quick storage. If it is not on dash D, with quick storage itself already, it's going to reuse the load module in quick storage, and then execute what? Execute the transaction. Okay, execute the program. As you already were, line by line. Okay, line by line till go back. Okay, here it's not go back. It's a command called return. Return is a command which is similar to go back. Return means the control will go back to fixed region. That's called return. Okay, anyway, we'll see there are levels like level 0, level 1, 2. We'll see slowly. Probably next week we'll see. Tomorrow we'll write a map set. Next week we'll write a pseudo conversational program. And then after you write for 3 or 4 programs, it will be very easy to understand further concepts. Okay, I'll go to the slide and show the slideshow. So if a user enters a transaction code, okay, on the top left corner, okay, in the computer in fixed region, okay, on the top left corner, it will come to PCB and check with the validity of transaction code and check whether you have access. Goes to TPD, check whether it is in storage itself or on disk. If it is in storage, it's going to execute, bring the copy of load module and execute the program. If it is not on storage, it will go to it locates the library. It locates the load module in the library. So these libraries will be concatenated in steplib in CACS jobs. Okay, and then it brings a copy engine to the cics address space and execute the program line by line. So this is what happens. If you give a different transaction, for example, this is not a proper valid transaction code. It's saying not recognized. It is not in PPT or PCT, program control table. And usually transaction code is alphabets, okay, and but you can have numbers also. But the first character always should be alphabet. Okay, usually it is alphabets, but it can have numbers also as a part of the name. But first character always should be alphabet. So this slide shows how cics is invoked. I'll share the slides which are I'm showing. I'll share the notes also. Okay, now everything has moved to API. Okay, probably I'll just show you what is API. Just let me come out of this slide. I created one diagram recent training. So I just want to know, show some evolution of mainframe on CSS perspective. So that is the reason I'm just searching for a slide. For example, I just write it here. So if you see where cics stands now, okay, for the last 30 plus years, we have ZOS, okay, we have IBM MF, and we have ZOS and cics as a job. And then cics will have 3 layers, okay, either presentation layer and business logic and storage layer. These are 3 tier. In 3 tier architecture, we have business presentation layer right here, the 3 tier architecture, which is commonly used in CACS. So if we see 3 tier architecture, we have a presentation layer. Presentation layer means creating a screen or a map set. Okay, here we call it as a map set. Okay, in some software, we'll be calling it as a form or format or a screen itself. Here we call it as a map set. Okay, map set. This map set is created through BMS macros. Okay, macros means it's a function. BMS means basic mapping support. Tomorrow we'll create a map set, okay, using BMS macros. Basically, these are macros. Okay, these are assembler macros. Okay, for example, then we have the next layer, which is a business logic layer. A business logic layer will have all the business logic like compute, if condition, okay, and evaluate condition. All these are business logic for checking here, checking that, etc. So any business logic is written using COBOL. The COBOL and cics commands. Okay, we are going to embed the cics commands in COBOL. In fact, in olden days, we have macro level programming, okay, wherein which will not write the commands. Okay, will will be writing in a different way. Very olden days, olden days, and in one or two companies still they're following even today. Okay, that's called macro level programming. But mostly, almost all the companies are following micro level programming. Micro level programming commands are embedded in COBOL. Okay, it could be COBOL or PL/1. Commands are embedded. Like how we embed a DB2 command query or SQL query in COBOL. Similarly, we are going to embed cics commands in COBOL. Okay, then we have the DB layer. Okay, we can say I'll instead of DB layer, I'll say data storage. Okay, data storage layer is very appropriate. So you can store in either KSDS files or DB2 or IMS. Okay, in fact, the IDMS is also there. I'm not telling IMS. In fact, we can remove IMS also. Okay, here we are going to use BMS to create map set. Okay, BMS are nothing but assembler macros, very easy to write. And the logic, okay, business logic is going to be on COBOL cics, and the data storage will be on KSDS or DB. This is a three-tier architecture. So if you see a three-tier architecture, we have COBOL, okay, an application program, which consists of the layers like COBOL, the cics, okay, which is business logic. Then we have BMS. Okay, BMS is okay. Let's take KSDS, DB2. Okay, DB2, which is the storage layer. Okay, storage layer. Now, this is the actual scenario in olden days until say 1980s, till 1980s. Okay, till 1980s, this is the scenario. So for if you want to till 1980s, if you're going to use CACS, if you're using CACS in your project, okay, anybody who is working in project or who is using the software like business office, branch office, call centers, etc., they'll be using kick screen. Kick screen is developed in BMS. So if you call it as map set, we developed using BMS macros. Okay, BMS using BMS macros, it is developed. Okay, now after 1990s, from 1990s onwards, okay, from 1990s, there are many new companies started bringing new different GUI based screens. The screens could be in HTML, okay, or it could be say in Angular. Nowadays, Angular, React. Okay. There are many software which provided better screens. HTML, CSS, like HTML, CSS, or it could be Angular and React. So these are some new technology with which we can create screen. Okay, with which we can create screen. Okay, now the screen is a new technology. Okay, so instead of BMS, we are having a new technology screen. And remember, this screen can be given to customers also. Until 1980s, customers were not given the access. In fact, we didn't have internet. Internet came into existence in 1982. When 82 to 83 it was started, and then slowly it picked up. Okay, we didn't have internet. After the 1990s, internet picked up also. So customers started using the software. Okay, but now we cannot show a UI screen to customer. Instead, we are developed in the screen. Okay, so data comes from which screen? From the screen. Okay, even Indian Railways, the ticketing system IRCTC, okay, is having a software. Okay, it's almost similar to mainframe, and they have a new technology screen. The screen can be is browser based. It can be accessed via internet from anywhere. Even we can have applications through apps we can access. Whatever data we are getting, it comes to the mainframe server, which is running in backend as a backend, and data is stored in either DB2 or KSDS. And since to talk to these, this will be in different hardware. Okay, this is a highly mainframe hardware. This will be a different hardware. Okay, different hardware. You can say new technology hardware. Okay, it's a new technology hardware. So this is a different hardware. This is a different hardware. You want to talk to these hardware. Okay, usually the application, the software which is going to connect these two hardware is message queue. We call it the MQ. So MQ is very common. Okay, when you connect across the hardware. So if you want to connect to hardware, you have to install the software in both the hardware so that these two hardware can talk. And usually the data transfer will be in XML, okay, XML or HTML, because XML is very flexible. It is going to be having a starting tag, ending tag. We can send a variable length data from this screen to this. Okay, a message queue will be receiving a request and responding to the request. Okay, so this is the scenario which is in current trend. So even though and even though even though Pixar has a map, nowadays no one is using map. These map sets are used by programmers. Programmers use this map set, or some old people working in call centers, they may be using this map set. Okay. So so it depends. Nowadays, the people who are using map set have come down drastically, but the programs residing in backend, which are huge, okay, for many companies, it's not still running in mainframe. In fact, 90% of Fortune 100 companies, 90 out of 100 big companies in the world, they are running their online transactions only in CACs. All these programs have become huge and mature. It's not easy to change the software. You cannot change a CACS program or COBOL Fix program to a Java or Python program. So they are, and moreover, it is working properly. So no one wants to retire this. Okay. So this is one hardware. This is another hardware. Okay, we are sending data to and fro this hardware using MQ. Apart from MQ, there are different software. There are different softwares like LU 6.2. I heard about IREP. Okay, and there are few more software available to transfer data from one hardware to another hardware and vice versa. Okay, and in fact, we are in real time on daily basis. We are doing this. Okay, we are having an Android phone, Android operating system phone with a different hardware. Okay, it could be a different hardware, Snapdragon or some other hardware. So assume we are sending to iOS operating system an Apple phone. So this is a different hardware. This is a different hardware, and different operating system. Different operating system. Okay, the command, the everything is different in iOS and Android, and you can send a message from in WhatsApp from this phone to this phone and receive back also successfully. Okay, so here there's a server also in between. It goes to WhatsApp server and then it goes to the other device, and again it comes returns back out. Similarly, we can send a hardware data across the hardwares, so from this hardware to this hardware, and vice versa. So this is the actual trend. Okay, even though CACS, you have to know where is the actual trend. The BMS is almost retired, and it is replaced with latest technology screens because it doesn't support GUI. This supports graphic user interface. And nowadays, I mean, even the customers are using the software. They have to see a proper screen. But the backend for many companies are still residing in CICs. So business storage, data storage and business logic layer still residing in mainframe hardware. So while the presentation logic has been moved out of mainframe to a new technology. So this started from 1990s onwards, and every almost all the companies have retired. Even in India, Reserve Bank of India uses, Indian Railways uses, IRCTC also uses, but the backend is still mainframe. Even NASA uses, Walmart uses, plenty of companies. Already you'll be aware which other companies are using. Okay, everyone have retired the online screens. Okay, and there are different technology apart from sending data via message queue. So we have screen scrapping technique. If you write here, it will write to BMS. Then it will send data to BMS, etc. Now we are ignoring this presentation layer. Okay, we are using only the business logic and storage layer. Okay, and now the program is called API. Okay, application programming interface. Okay, so it's going to be an interface. It's going to interface with the new technology screens. Okay, so this is the diagram. I wrote a good diagram, drew a diagram, but it's not there. So here there are something you have to know. So a BMS provides the interface between programs and terminal control. Okay, anyway, the BMS acts as an interface. When you invoke any screen, BMS snapshot will come and a program will be at the back. Okay, so all these are just on a high level. Okay, high level because as I told you earlier, application. So OS under OS which is running as an address space. Okay, and program is running under cics. Program can request for file. Okay, say a vsam file or a db2 table or an imsdb. So for everything we have a interfacing program. These interfacing programs are called control programs. So we saw about control programs, right? So these are the control programs. Control programs acts as an interface between application program, okay, to provide the services requested. Here, what services it's requesting? File related services, storage database related services. Okay, only it's going to only rewrite and delete. Okay, it could be in file or database, doesn't matter. Only four services are requested. Okay, so we just saw on a high level what is CICS and what is the transaction or transaction code. What are the components of a CICS? Okay, where does this come in? This is really fitting in today's world, and we saw about few more concepts in CICS. So we saw about the architecture and how the architecture has changed in today's world, where presentation layer has been moved out of mainframe and then we have moved to new technology scheme. I'll create a transaction code. So here, as far as cics is concerned, we have to embed the command between two delimiters, exec cics and end exec. Like how for DB2 we SQL queries, we give exec SQL end exec. Similarly, exec cics and end exec. And the command for go back is we called as return command. Okay, here we don't use go back, we use return. So let me define a transaction. Okay, if you define a transaction, we are going to use CICS OZA region and OZA GS code. Water is a password, and I'm going to define a transaction. So, so for defining any defining anything in the tables, okay, control tables, we use a command called seda. Okay, this any transaction code, if it starts with C as a first character, it's a system transaction code. Okay, we have many transaction codes like CMT, SEDA, CEDR, CEDF, CECI, etc. SEDA is used only by administrators, but since we have in this training meeting, we have administrator access. So we can define any transaction code in tables. Okay. So I'm going to define a transaction code, and every transaction code should be defined in a group. So we have to usually the user ID is a group. Okay, let me write it before what we are going to do. We are going to define a transaction code in PCT. Okay, along with program name. Okay, along with program. Okay, and remember, whenever you are defining anything in tables, the control table, it should be in a group. Okay, and a group name will be usually will be user ID. You can give any group name. In fact, group name will be user ID. Okay, then I'm so after defining a transaction code, we have to install the transaction. Install means you are going to enable the transaction code. In fact, if you want to disable, you can uninstall the transaction code. Okay. So until it is installed, it is not active. Then define a program PPT, and again it will be in under group name user ID. Group name I'll write user ID. So okay, again you have to install. So to activate the program. Okay, then should be in which environment? In cics environment. Okay, then we can write a program. Okay, write a program and compile the program. Okay, again then you can do execution. Okay, execute the program. Okay, I'll just show you a small program, very simple program to send a text to the screen. Then, so um, earlier in olden days we had macro level macro level fixed programming, where in which we give macros. Macro means copybooks or functions, and then we change. And then mostly many companies are using command level. Macro level is in fact easy, but you have to understand how it works. Okay, that will be a little bit complex to understand. I've seen macro level programming in a project called APL. Okay, other than that, I've seen many projects, but I've now never seen macro level. Okay, everyone uses only command level. In command level, we embed the commands. Okay, in any host programming language, okay, like COBOL or PL1, and then we give within delimiters XX, CSS, and exit. Now we are going to define a transaction code and then install the code, define a program in PPT, install the program. So that PCT entry and PPT entries are satisfied. Okay, I'm going to use one PDS cics.sourcefile. Okay, I already have written few programs and I took a training long time back, some 6 7 months back. I'll give the IP address and port number. You can. Okay, Mocha software is a terminal emulation software. Okay, that software we can't connect. We need to have IP and port. Then user ID and password. PSU, user GS4. Yeah. So here, yes. So I'll write a program OSA G4P5. Okay, OSA G4P5. Yes, OSA G4P5. Edit, copy OSA G4P5. What I'm going to do is I'm just going to uh, write a program to send a message to screen. That's all, nothing else. Okay, the program OSA G4P5. Okay, I'll make it as welcome message. All right. welcome to cics programming. Okay. All these are built. Okay, I have to explain about DFH com area, etc. Okay, I'm not doing all these. Take long for the first program on pseudo conversation. Definitely will take some time. I mean, for me to time. Tomorrow, next week, we'll write the first program. It will take at least 3 hours for me to explain that. If you understand the concepts of pseudo conversational programming, then it's going to be very, very easy. And understanding is also very easy. Okay, I'll just so this is a very simple program which is going to send a welcome message to an online screen. So all the kicks commands will be embedded, okay, within kicks, exec series and index. So here I have just a welcome message, okay, 40 bytes, welcome to kicks programming. And we have two kicks commands. To write return, exec series, return, end hyphen exec means it's similar to go back. Okay, it's similar to go back. So if you take even in a batch program, okay, in a batch program, what we do, we have a ZOS, and then under that JCL will be executing a batch program. Okay, and we give go back. We give go back in a batch program. The control goes to the operating system. Okay, then operating system will do all its formalities like closing the file properly, closing the database if it is not closed properly, etc. So all these it is going to do. But if it's similarly a return, the return command will send control back to kicks region. Remember, a kicks program is executed as an application program under the kicks job, okay, kicks region. And there are a lot of management program which is called L. So here we are seeing one more command, send text from any field. Erase means, so we are telling the system to erase the screen and then send this. Because a terminal can be used for anything. Okay, so when the terminal has already some data on the terminal, so what erase will do, it's going to erase and then send. Okay, erase and then send. Okay, free KB means you're telling the system to free the keyboard. Remember, so Kix was designed in such a way, okay, it is going to give indication to keyboard by way of sound. Okay, okay, the Kix, I mean the mainframe keyboard. But since we are not using mainframe keyboard, okay, it is replaced with the Windows keyboard. Okay, so sometimes the Windows keyboard will get logged. That's the reason we are saying free KB. The free KB, in fact, it's not required. Anyway, we'll be using tomorrow. Tomorrow, when we use BMS, then we will use free KB. But as of now, erase is enough from welcome messages. Let us compile, save. Very simple program. It's a non-conversational program, meaning there is no conversation. If you have map set, we have a conversation, right? We have a screen means a user is conversing with the program through the map set. Okay, we are having a dialogue between a user and the program through map set. It's a two-way conversation. That's why we call it dialogue, and we call it as a pseudo conversation. Okay, we see a pseudo conversation. So the program which you are running is a non-conversation. Okay, what I'll do, I'll just write it here. So we can say there are three types of programs. Okay, three types of programs in Pix. One is a non-conversational, where it's a one-way traffic. Only one way we are sending information. Okay, it's a conversational. Conversational means it has a map set. Okay, a map set will be there. So through a map set, we'll be talking. User will be entering data in the map set. Once they enter data and press enter key, the data from map set will go to the program. Program will edit, will check the validate the data and then send back any error message or success message. So there's a conversation happening between the user and the program. Okay, so the conversation is will happen. Okay, will happen or is happening between the user and the program through Mapset. So Mapset is like an interface between user and the program. That's called a conversational program. We have another set of program called pseudo conversation. Okay, now we are writing non-conversational, and tomorrow we'll design the map set, and next week we'll write a pseudo conversation. Once you understand one program in pseudo conversational, and if you write two or three programs, then it's going to be easy for you. Once you know the concept of pseudo conversation, then we can add other concepts: how to use files, how to use database, how to use a TSQ, TDQ, etc. very easily. Okay, the main idea is knowing what is pseudo conversation and how to write a program. Okay, again, map sets. Okay, now it's called a pseudo conversation. Means what? It's a false conversation. Pseudo means false. Okay, so a conversation is happening means there's a single task running. A single task will run for the program. It's going to be a single task where user is having a conversation program continuously back to back until the program until the data is has been accepted by the program. Remember what people do through online screen. One either they're going to add some data or change some data, inquire some data or delete some data or list some data. If they're going to add, program is going to verify, validate, and send back any error message or success message. That's a conversation happening. So there'll be a continuous conversation between the user and the program through Mapjet. And for and if you have a conversation program, there's going to be a single task. A single task. I'll come to pseudo conversation in detail next week, okay? Because this is a big topic. You have to cover, take at least 2.5 3 hours. But today I'll touch base on pseudo conversation on a theoretically because only if I cover today, uh, okay, next week it will be easy for me to write a program and show you. Today we'll see what is pseudo conversation. Just see okay, quickly after this. But pseudo means it's a false conversation. It looks like a real conversation. It looks like a real conversational though. Okay, it is no. It is going. It will be taking. It will be done in more than one task. Okay, it looks like a single task, but it is more than one task. So this is a major difference between a conversational and pseudo conversation. Conversational means a one task. Pseudo means as many tasks. So we'll see that quickly. Okay, we'll see that quickly after writing this program. Okay, now we are going to write this program, a non-conversational program, wherein which there is no dialogue happening between the user and the program. That's only one-way communication. Let me save this. CACS day one, right? Some 30 back, right? 32 or something. I'll just share with notepad. Okay. So what we are doing, we are just going to define a transaction code and then along with the program, install that, define a program, install that. We already written a program. We are going to compile now. And after defining, we are going to execute the program. Or what I'll do, I'll just cut this and write it here. Okay, and then I'll remove this. This is what we have done as of now. Okay, we have written a transaction code. So write a program and compile. We are ready to compile. Okay, let me edit the program one more time and show you. So Obra GSO water. Okay. Just a welcome message and send text from welcome screen. Erase. Okay. If required, I'll be adding free keyboard, free keyboard, then return. Oza G4P5. So we have Kix compiler. The Kix only this program is here. Let me submit this to max 0. So this will be placing the load in Oza ADM.kix.load link. Okay. And I logged on to Kix Oza region. Okay, let me go to school. Right. Yes. Yes. Okay. Owner star prefix Kix star. You can see Kix Oza is running as a job. Okay. I don't have access. I think we don't have any admin data sets, admin IDs. Yesterday I was using one admin ID. I don't know whether it's working today. Let me try now. Just hold on. Okay. So if you have admin access, then you can log on and see the load model. Okay. In product, I think you'll be having access. Okay. You can go to the JCL, JES. You can see the JCL of CACS job. You can see all in the step list. Okay. All the load model libraries are concatenated. So here I just compile. Okay, I just compile, and then the load model will be in x.load link. Those are just .x. So okay, we go to Cobol Fix compiler. So this is the place where we compile, and this is concatenated in Fix Posa job, which is running in school. And if you want to, you can see manually also. Okay, anyway, as you're already aware, since you're seniors, Posa G4P5 will be in this log link. Now it's in DASD. Okay, it's in DASD. It's not in its memory. Okay. Now let us go to open another session. So we log on to Kix region. So if you want to log on to Kix region, in some companies it will show user ID and password. If it doesn't show user ID and password, you can give a command called CESN. Okay, Kix commands. CESN. CESN for signing on. Click Kix, execute, sign on. So you can give user ID and password. Okay, then you can get into Kix region. In many places, when signing on, it will not ask. Okay, but by default, it will sign on based on the TSL credentials. Otherwise, you have to give user ID and password. Okay, depending upon how it is set up in your installation. Okay, sign on and sign off. Then there's another command CSF good. Good means CSF good night. Okay, again check execute sign off. Okay, now I'm going to give the command SEDA define transaction transaction code. I'm going to give the program name is OSA G4P5, right? I'll give OZP5. OZP5. Program name is OSA G4P5, and group will be OSA GS4. So this command will be defining a transaction code OZP5 is a link to program OSA G4P5 in this group OSA GS4. I will copy paste this command. Okay, here. Okay, I'm going to press enter. You'll get the screen define successful. It has created transaction in this group. The program which is linked is this. It is enabled. If you want, you can disable the transaction. And these parameters will be changed only by the administrator. So whenever you see function keys at the bottom, okay, you have to press F3. I'm pressing F3 now. If you want to clear the screen, you can use clear screen in the software. Otherwise, you can use clear screen in your keyboard also. Either you can clear the screen by using typing. There's something called pass break. If you go to in some keyboard, we have pass break or clear. If you type press that, it will clear the screen. Otherwise, you can clear like this also. Using the emulator, you can clear the screen. There are different logical kicks regions. Okay, I'll tell you later once we learn link and XCTL. But currently, just follow whatever I'm doing. I just defined. Now I have to install. To install the transaction code. So installing, the command is seda install. INS. So I am giving all these commands is you can try and see. You can define your transaction code, write your program, and execute and see. As far as kicks is concerned, only if you execute and see, you'll get confidence. Okay, otherwise you'll never get confidence. So I'm going to execute this transaction by installation. So you have to get install success. And whenever you see function keys at the bottom, press F3. Again clear. So installation is done. Now I have to define in PPT. If you want to see whether you have defined in PPT or PCT, CMT, enquire, transaction. CMT means clicks execute master terminal. Okay, master terminal. You can give transaction code. Okay, you can give this. It's going to say this transaction code is linked to this program. It is enabled. Okay, similarly, we have CMT enquire program name also. F3 clear. So I'm giving all the transaction, all the commands. Now we have to give an entry in PPT. Okay, for PPT, I'll just copy this. Okay, I'll remove this. That's all. So this will enter information in PPT. Okay, Cheddar define program in group. Okay, define success. Don't worry about all these. This is not your job. It's going to be done by Kicks admin. Press F3. Even in SEDA also will be done by Kicks admin only. The SEDA install. I'll just copy this. INS. Clear screen. Install. Press F3. Okay, F3 for end. Clear screen. So now, if you want to inquire CMTI program, it will work. It will show the CMTI program name. It will show the PPT entry. Now the definition is done. Program is executed, compiled. The load model will be in DASD. Okay, it will not be in fixed memory. Okay, it will be in disk, not in fixed storage. So now, when you execute the program, by entering the transaction code on the top left corner, it will search in PCT first. If it is present, it will know the program is this is the program. From this program, it gets into PPT. It is going to see where the load model is present, whether it is in storage or it's going to be in dash D. Since for the first time it will be in dash D, it is going to bring a copy of the load model of program from dash D to storage and then execute. Here everyone have access. That's the reason there is no backup for cics region. In project there will be a backup. Here there is no backup at all. Everybody can use anybody's transaction code in cics region alone, not in TSO. So this program will erase the screen and then display a message. Welcome to cics program. So I'm clearing the screen. They ordered OZ P5 the top left corner. So only the top left corner. You should not give one space and write. If I gave two spaces now, it will take two spaces and OZ as the transaction code. So it says transaction not recognized. Even if you give one space also, it's not correct because it's not the proper transaction code. Okay, because it is going to expect in the first 4 bytes in the first row. Okay, so this is how it works. So what I did, I wrote a small program, okay, which will send a text um, from the screen to the screen. Okay, I'll give you the location of the program. Just hold on. The program is in this location. So once I give the access to the user ID and password, okay, you can create your own library. You can write ozgs4 dot. This is compilation, and this one will be source code. Okay, this is how and we can define and install, and then we can execute a simple program. So let me get into one important concept, and then we'll work. So you can see a screen. Okay, if you take any screen, if you first you're going to enter a transaction code, it shows a screen. Okay, then what really happens? So once the screen is shown to the user, okay, what user is going to type the data. Okay, after typing the data, they are going to press enter key. Okay, a screen could be either an inquiry screen, or it could be a add screen, or retrieve and changing screen, deleting some entry, or listing screen. Okay, in fact, there are four major functions. One is read, write, rewrite, and delete. Read is nothing but inquiry. Write is just adding, and change is nothing but rewrite, and delete is deleting a record or in a row, in a file or a database. So these are four major screens you'll be seeing. Now, along with that, you'll be seeing a list screen. In list screen, we'll be having more than one data. Okay, we will look at the screen later. So in either screens, for example, if you take a read screen, okay, so if you take a read screen, there'll be some data will be as an input, some data will be an output. So I'm just discussing about the screen, okay, about the screen, how program works on a high level. Okay. Anyway, next week we'll be seeing in a detailed level on how screen works. So if I let me stop the slideshow, I think if I write, it will not show. I think okay, until I stop the slideshow, probably I'll remove this. So if we take a screen, so we'll be having input and output fields. Okay, if we take a screen, you can see there are input fields and output fields. Okay, for example, if it's an inquiry screen, okay, we are giving some input. So let's take this example itself. Customer number is input, name and address is an output. We're giving customer number. Okay, and output is name and address. Okay, this is output. So what customer is really doing, so when you give this screen to the user, first time it shows an empty screen. And user is typing the input data and press enter. Okay, and then the program process the data from the screen and then sends back some message. Okay, what it sends back here, it is going to send back name and address, provided the customer number is found. Okay, see, I'm just discussing on how a screen works. Okay, normal terminologies, normal functionality of a screen, and you also have to see how a screen will be, a normal screen will be, so that you know how to design a screen also. For example, if you see a screen here, it's a standard screen based on all coding standards, okay, which are followed in mainframe. Coding standards is we have a screen title. You can see a title. We have the transaction code here, and you can see a program name here, and we are seeing labels. Okay, we are seeing labels. Labels means these are display only fields. Okay, these are display only fields, and then we have data entry fields. Okay, data entry fields could be either an input field or an output field or an IO field. Okay, we have to understand about a screen so that we can design a screen very easily. That's the reason we are saying this. We have to again end the show. So if you see a screen, if you take any screen, okay, if you take any screen, so we have a title. Probably I'll just go to the same notepad which I'm using. This screen. So we have a title. The screen will have title and program name on the usually on the left corner, okay, top left corner, and then we have the transaction name or transaction code in the top right corner, and we have different fields that we call labels. Labels are display only fields. So these are fields which are protected. We can't type anything. So these are protected. Okay, these are protected. Protected means you can't type. There are other fields which are called data entry fields which are unprotected. Okay, these data entry fields. You see data entry fields, it could be either an input field which user is going to type and give information to the program. Okay, input field which is usually unprotected. There could be the output field. Okay, output field means what? Data comes from program, program to mapset. Okay, so here data goes from mapset to program, and this is unprotected. So unless it is protected, you can't type. Okay, similarly, in output field, data comes from program to mapset. These are output fields. Output fields should not be protected. That should not be unprotected. It should be protected. Okay, so either input field, one or more input fields, one or more output fields. Okay, and third type of field is IO fields, input and output fields. So input and output fields means it will be data will be there, will be shown in the terminal. Okay, shown in the terminal always. Okay, it will be always unprotected, and this data can go from screen to program or map set to program and vice versa. We can, so in either way we can use it. So if we take a map set, if we take a screen or a map set, so this is the layout. And apart from that, you can see few more things. You can see a function, right? You can see, because in mainframe we can assign functionality to every function key in the keyboard. Okay, we can assign functionality to every function key in the keyboard. So we have list of function keys, okay, with functionality, okay, with shown with functionality, which functionality the function keys is going to have, okay. And then finally, so one is hidden. Actually, one is hidden. Okay, you can guess what is hidden. Can it guess what is hidden? What is not shown in the screen? So we saw a title. We can have one or more titles. We can have one or more headings also. Then we can have display only fields, data entry fields, function keys, program and map set, and then transaction code. You can see here. What is this? This is a message. Okay, this is a message. Okay, this message is could be either an error message or success message. Okay, it could be an either error message or success message. Usually, a message will be returned before the function keys in the screen. So, okay, usually it is written before the function key. That's the reason I'm just giving in sixth. So we are having message. The message is it an input field or output field? The message comes from a program to map set. Okay, so it's going to be an output field. Message is always an output field. Okay, this is what any design, and we have a set of standard variables and standard code, color, etc. that can be used. Okay, and the screen or map set. Okay, let us call as map set hereafter. There will be 24 rows and 80 columns. Okay, 24 rows and 80 columns. In fact, we have something called maps. A map set can contain one or more maps. Okay, maps means a maps is a subset of map set. Okay, yeah, we can split the map set into multiple maps. Okay, for example, first 12 rows and 80 columns, half of the screen we can have one map. Remaining half, bottom half, we can have another map. There are two maps in the map set. Okay, or we can have a small place here, a single map. Remaining can be another map, or vertically also we can split. Okay, so map set can contain one or more maps, but usually in projects we'll be we'll be having we'll be having only one map per map set. Okay, we are not going to have multiple maps in a map set. This is what is being followed for many projects. Okay, now let's see something about what is really happening in a map set. Okay, just see the steps. Okay, let's see the steps that is really happening. That will give you some idea of what is happening in the program. So if you see a first screen, what is shown? An empty map set is shown to the user. Okay, this empty map set will come from program to terminal. Okay, an empty. So first process is in an iteration, an empty map set is shown to user, okay, from the program. It comes from the program. Map set is sent from program. Program to what? To terminal. So see, if you understand how this works, you can understand pseudo conversation very, very easily. But anyway, next Saturday, we'll be writing a pseudo conversation program because tomorrow we have to we'll be writing a map set. So tomorrow we'll be creating map set. Okay, first is iteration. This is first iteration. When if a user is typing, okay, the user is typing the transaction code, the very first thing which is going to happen is an empty map set will be shown to the user, and this map set is going to come from program to terminal. Then what's going to happen? It is going to wait for the user to type the data in unprotected fields. If it is customer inquiry, user is going to enter data in customer number or primary key. This will go to the program. Program is going to check whether customer number is a valid number. If it is valid, it's going to process. If it is invalid, it is going to show an error. Okay, if it is valid, it is going to process, pull the name and address, and show to the user. Because basically, this screen is an inquiry screen, which is going to take customer number as an input. It's going to give name and address as an output. Okay, if you take any online screen, okay, it will be we are going to get data from the screen to the program. We are going to validate the data if the data is correct or not. The validation phase will be showing an error to the user. The user will again change the data and again send the data to the program for processing. Again, validation will happen. If the validation is successful, then processing will take place. Then we'll process the data, and then finally we'll send the message, success message. So this is what is happening in any screen, in any technology. We get data from screen, process, send. If it is invalid, send an error message. Valid means process and send a success message. While processing, we are going to apply the business logic, and then we can store or retrieve the data from storage layer, either KSBS file or database. So, first iteration, an empty map set is shown to user. Map set is sent from program to terminal. Now, I mean, user has to has to input the data. Okay, input the data in where? Only data entry field, in unprotected fields. So user has to input the data in unprotected fields, all data entry fields. Then what they do after entering all the unprotected data, they press enter key. In modern day, it's a button, submit button, etc. So when you press enter key, what's going to happen? Data goes from screen to program for processing. Okay, for processing. Well, I'll go to the third step. Program will be validating the data. Okay, validating the data because it should be in that format, correct format. Okay, if validation fails, throw an error, or we can say send an error message back to screen. Okay, back to map set. I'll write here instead of screen. Let me mention as map set itself. The empty map set is sent from program to terminal. Okay, user terminal. I'll write as user terminal. Okay, use data goes from map set to program for processing. If validation fails, send an error message back to mapset and back to terminal. Okay, terminal. If validation is successful, okay, if validation is, if you understand this, you can understand how to write a pseudo conversation. But again, I'll be dealing with this in detail. Then I'll be converting this as a code. Then I'll enter the code in mainframe. Then I'll execute and show you the first pseudo conversation program. So if validation is successful, so these are two chances: either successful or failure. Process the data. Okay, apply the business logics. Okay, and store or retrieve data, okay, from KSDS. I'll write KSDS DB2. Okay, then send what? Send a success message. Okay, send a success message back to screen. Send a success message back to terminal or maps it, or we can say user, whatever. So this is what happening. The first time when any user opens the transaction code, okay, an empty map set will be shown. Then they can input the data. The data is validated. They can see either success message or error message. Then they can do in a multiple iterations. Okay, so I'll say second iteration onwards. Okay, first iteration they are seeing, first time they are entering, they are seeing map set. Okay, then okay, I'll remove this second iteration onwards. Input data. Okay, now the first time they are entering, they are seeing empty map set, entering the data, and pressing enter key. Program is going receiving data and processing and sending back the information. Same thing is going to repeat, right? Repeat. So if they want to, suppose it's a data entry operator, they'll keep adding. So they'll be keeping repeating, repeat steps 2 to 3. Okay, we're going to repeat steps 2 to 3 until we decided to log off. Okay, not log off, decided to exit the screen. Okay, so you can assume it's a data entry operator. Right? They can do inquiry or add data entry based on a paper. They can change the data based on some inquiry. They can delete something which is off the list. Okay, so they are going to repeat. Then they decided they are done the work. They can exit the screen. This is what is being done. Okay, if you take steps in a conversation. Okay, in a conversation, null programming. This is what is really happening. If you understand this very clearly, then you can write a program very easily. And it's understanding this is not a big deal. Steps in a conversational programming. First iteration, an empty map set is sent from program to terminal. First time, the user input the data in all unprotected fields. Press enter key to process. Data goes from map set to program processing. Program will be validating the data. If validation fails, send an error message. Validation successful. Apply the logic. Send a success message. Repeat the steps 2 and 3, okay, until the user decided to exit the screen. Okay, I'll show you the here also. Okay, for example, if you see here, first time user pressing the transaction code, say INQ1, for top left corner, it is invoking an empty screen. So this is an inquiry screen. In an inquiry screen, you'll be giving a primary key as input. You might be getting back anything else. Okay, here primary key is a customer number, and then we are going to display name and address from a KSDS file or DB2 database. And remember, the customer number should be a valid. If if it is not valid, you have to say it is invalid. Okay, the way the syntax is in, the format of the customer number is invalid. If the format is correct, the customer number is not present in the database, then you can say it is not found. Okay. So here in this case, user is typing some data, okay, and pressing enter key. Now program this data from the map set goes to the program for processing. Okay, this is second screen where user is typing the data. After typing the data, they are going to press enter key. Then assume this customer is a valid customer if it's present in database. If it's present in database. Okay, so we're going to do a reint random or select if it's a DB2 query. Then move the data to the output protected fields and then send the snapshot to the screen. Snapshot to the terminal. Here we are going to see in detail. Just understand on a high level. Suppose if the customer number doesn't exist, it is going to show invalid. So whenever you design a screen, you are designing properly up to standards. And whenever you are writing a program processing data from a screen, you have to look for all the combinations. All the combinations, you have to give a message. Either it could be a success message or an error message. Okay, so this is what is done in a conversation. In a conversation, first the empty map set is shown to the user, and program is waiting for user to type the data. The user types the data, and then we are receiving, processing the data, sending the message back to the user. And this we are doing in a loop till we decide to come out of the screen. So I'm not going to go beyond this because that is a pseudo conversation. I just want to give a high level heads up since we had time. I don't want since we had time. Okay. See, in fact, the cics is in fact very easy. Okay, I'll show you one analogy. For example, you would have written a lot of programs, right? So you would have written a lot of COBOL program, which is accessing data from a file. Okay, we have file with records. It could be a VSAM file or a PS file. So what you do, you read command. Okay, read. What does read do? Read is going to bring one record. If you are reading for the first time, bring first record from file to the working storage. Okay. So when I'm going to read the issue read command, it's going to bring the first record, the very first read command will bring the first record from a file to working storage. Then you are going to apply the business logic. Okay. Suppose you are going to write record into an output file. It's an opposite. Suppose you are going to write record this, write the same record in an output file. Okay. The output file. It's very easy. You would have done this many times. So forget about first record or second record. What we do, if you have an input file and output file, we read the record from a file, process, right? We are going to process and we are going to access the storage. Okay, DB. Yeah, you can process. You can process. In fact, file or DB is here. We are going to read the file and then process and write. Because this we would have done many times. If you want to read multiple records, we do in a loop. That's all, right? So you're going to read in a loop and then read until end of file is reached. Suppose assume you are reading only one record. So reading one record from input file, process, write into an output file. Similarly, if it's COBOL cics, okay, this is COBOL batch program. If it's going to be COBOL cics, the data comes from where? Data comes from the data is going to come from a map set. Okay, you're going to process the data from map set. And then you're going to write Data back to where? Again maps. Okay, this is the only change. In fact, here the command is receive, and here the command is set. That's all.
Send map. Yeah. Map or data.
So,
Yeah.
so here we used to get, we have written plenty of programs in getting data from a file, process, writing it an output file. Similar way, you are going to get the data from mapset now to the program using receive command, process the data, and then send the success message or error message or whatever back to the mapset. That's all. So if you understand this, okay, if you understand this, okay, it's going to be much easier. In fact, I'll be dealing with this in detail. Okay, now I just built on a high level. In detail, I'll be telling this again next Saturday, and I'll write a program and show you. Probably I'll write a calculator program. Okay, we can have a calculator screen, and then I'll write a program and show you. So now what we are seeing today, we saw what is CICS, how what are the components of CICS, some concepts of CICS. Okay, what is the trend of CICS? Like, I mean, the BMS being retired was already retired for all the companies, especially for the customers, and how to use SEDA to define and install a transaction or a program. I wrote a small non-conversational program and executed the program in online. Okay. And we saw how to design a map set. Tomorrow, I'm going to write a code for map set. Tomorrow, we'll write a code for map set and we compile and execute. That map set will be using for next class. So we'll be writing a program for that map set. And I'll be giving some hands-on exercise also. So I'll be expecting you to do the hands-on exercise. And as far as cics is concerned, unless you practice, it will not come. Even if you can understand, but still you have to practice. And if you see any conversation, okay, when a user is kicking off a transaction, first they are going to see an empty, then they'll add, then program is going to receive the data, process, and send back the data. And this is going to be in loop. Loop in the sense the user can repeat the same inquiry or add data into the database or a file, whatever. It's an add entry screen till the user exits the screen. The user decides to exit the screen. Usually F3 is used for exiting the screen, like how you F3 is used for going back in PSO environment. Similarly, in online also, F3 or F12 or use function keys in which we've set functionality to exit the screen. And for exiting the screen, the command is very simple: return. Return is a command we give for exiting. It's like go back. And a small analogy of how a COBOL batch program works and then how a cics program works. So we get data from the map set to the program, okay, and then process send back the data back to the terminal. So when you press enter, the data comes to the program. Then we can send map set to the program. And in programming is very easy. So tomorrow we'll start BMS. Okay, tomorrow we'll start BMS.